All right, today we are talking about a dilution calculation, okay? So yesterday we talked about molarity, and that's the concentration of our solution. Well, what if we have a concentrated solution, one that is more concentrated than we want? How can we properly dilute that solution to the correct molarity? So one of the most practical applications, I do this all the time actually, is some chemicals are sold as pre-prepared concentrated solutions. So like all of our acids, hydrochloric acid, sulfuric acid, nitric acid, acetic acid, they come in these very scary looking jars that are like 16 molar, 12 molar. And that is really not a terribly safe molarity to work with, especially for high school students. So we take these solutions, we call those stock solutions. Okay, and they have to be diluted before they can really properly be used. So why don't we just buy them the way that we want them? Well, because it's more expensive to do it that way. If you think about it, to dilute it, what we're basically going to do is add water, right? So we buy the much more concentrated version, and then we add our own water, and that way we're not having to pay to ship water all over the country. So in order to do this, it's actually a pretty straightforward calculation. We use V1M1 equals V2M2. I call this voom voom. Okay, some people call it M1, V1, M2, V2. I like voom voom. We're going to voom voom. M1 being the molarity of your stock solution, V1 being the volume of stock solution, M2 being the molarity of your dilute solution, and V2 being the volume of your dilute solution. So let's look at a couple examples of this real quick. How much 12 molar HCl is required to make 2.50 liters of a 0.5 molar solution? So the most important thing is to keep the two sides together. So this is going to be our dilute. So this is our M2V2. And then this over here is our M1. Okay? And they're asking how much, so they're asking us to solve for V1. Okay? So our equation, V1M1 equals V2M2. We are going to solve this one for V1. So remember, we're going to pick up everything touching it and move it to the bottom of the other side. So our our V1 is going to be equal to our V2M2 divided by M1. So now I can take and substitute in our values. For V2, we had a value of 2.50 liters. For our M2 of our dilute solution is going to be 0.500 molar. And then our M1 was the 12.0 molar. Okay? So molarity is going to cancel, leaving us with our answer in liters, which makes sense for volume. Remember that since this is a fraction, we want to put the top in parentheses because there's more than one number. So we're going to do parentheses 2.50 times 0.5, close your parentheses, divided by 12.0. That gets us a V1 value of 0.104 liters. Now looking at our sig figs, that's the right number of sig figs because we had 3, 3, and 3. So don't forget to watch your sig figs when you do this calculation, because sometimes in this case they were all the same, they were all 3, so our answer should have 3. But remember, it's always the least number of significant digits. All right, let's look at example number 2. It says, what volume, so we're looking for a V there, of a 1.5 molar solution can be made using, there's our M1V, or our M1V1 are over here. So this is going to be our M2, and this is going to be our V2. So we have V1M1 equals V2M2. In this case, we're solving for V2. Okay. So we're going to take what's touching V2 and we're going to pick it up and move it to the other side on the bottom. So our V2 is going to be equal to V1M1 over M2. All right, so now we can substitute in our numbers. The V1 was 0.250 liters. Our M1 was 18.0 molar. And then our M2 was 1.50 molar. So molarity is going to cancel again, leaving us with liters. Liters makes sense for volume. Okay. When we put this in the calculator, remember we want to put our parentheses around the top. So we have parentheses 0.250 times 18.0, close that parentheses, divided by 1.50. That gets us a volume of 3.00 liters. Remember, 3 sig figs, 3 sig figs, 3 sig figs, your answer has to have 3. When you get a nice little whole number like that, it's perfect 3, just add 3.00 to get your 3 sig figs, and there's your final answer. So, that's how to do it.